Alright, today's tutorial is about symmetry in functions, which determines even and odd functions. So there are two kinds of functions, obviously, even functions and odd functions, and how we determine that is related to something about adding in negative inputs, negative x values, and whether or not the graph is the same or the opposite or completely changed, which is actually, there's three types of functions. There's even, there's odd, and then there's functions that are neither even or odd. So when conventional math textbooks and professors try to teach you about even and odd functions, plug in x, do this, plug in negative x, get this, stuff like that, they often forget to tell you or just choose not to tell you or expect you to know that f of negative x, alright, plugging in negative x is equal to, um, when you have the function x squared and you plug in negative x, you actually get negative x squared. And then x times x is a positive number, so you have an even power here, and you should get a positive number all the time. So we just say that that's equal to x squared. We keep the exponent, but we get rid of the negative, because it doesn't make sense to have really a negative x squared. I mean, you can, but it's more like negative 1 times x squared. So just keep this in mind. And that's for even functions. So I'm going to get rid of this, and I'm going to show you how to find out whether a function is even or odd algebraically. A function is even if, when you plug in f of negative x to your expression, your equation, a function is even if you get f of x. Alright, so plug in f of x and then get f of x. So I'm going to find an example from the text that we're following. F of x is equal to 1 minus x to the fourth. So if we plug in negative x, you get 1 minus negative x to the fourth. And this is an even power, so your x will always be positive, which gives you 1 minus x to the fourth, which is the exact same thing as the original equation. Therefore, this function is even. This function. Now let's look at an odd function. An odd function is defined as algebraically as f of negative x is equal to negative f of x. Alright? And an example for that would be f of x is equal to x to the fifth plus x. So, what do? We plug in negative x. Sorry about the lawn mowing people, they're still mowing those dang lawns. To the fifth plus negative x. And this is technically 1 to the power of 1. So these are both odd exponents, and anything to an odd exponent, if it's a negative, will come out negative. So we can rewrite this as, I didn't really need to rewrite this, I don't know why I did that. Negative x to the fifth minus x. And what do? We can take out a negative, right? We can take out a negative from this, and we get, I don't want to rewrite it, negative x to the fifth plus x. And look at this. Oh, I don't need it. this expression right here, x to the fifth plus x, is the same thing as this, except it's negative. And that satisfies our definition of an odd function. You have f of x with a negative. This is f of x, and this is f of x with a negative. So it is an odd function. F of x, in this case, is an odd function. Okay. And then there are cases when you will have neither. An example being, let's do h of x, because no one ever does h of x anymore. 2x minus x squared. And all these equations that I'm writing down are examples from example 11 in the book if you're following along. So let's plug in negative x. H of negative x is equal to 2 negative x minus negative x squared. Alright, so this turns out to be positive. So positive x. And this is an exponent of 1, so it's going to be negative. So negative 2x minus x squared. Because this turns out to be positive. I don't want to do that. It turns out to be positive when you bring it down here. And this makes it subtraction. So, is this whole thing the same as our original? No. So it's not even. Is it the whole thing with a negative? No, because if you take out a negative, this becomes positive, and that's automatically different. So it's not odd either. It's neither. I don't even know if I spelled that right. Neither odd nor even. That's what this function is, h of x. And you'll notice too, it has two different types of exponents. It has an odd exponent and it has an even exponent. And sometimes when you have that, it can make the whole thing neither odd nor even. So that's just a quick run through of odd and even functions and symmetry. I'm going to continue this in another video because I don't want this video to be super long. So look for the next video and where I do symmetry, where I show you the symmetry part.